All right, hello HBS. This video is to walk you through a sample spirometry graph and how to draw it. So the first thing that I always want to do is draw the squiggly lines associated with a normal spirometry graph. It's always kind of fun to draw because it's just a bunch of squiggles, but generally it looks kind of like this. Okay, so now we are going to go through each specific part of this spirometry graph and what the heck it means, because it's not actually just a bunch of squiggles. So this first peak that we want to talk about right here is what normally happens when you take a breath. We call that the tidal volume, or TV, because it's kind of like the tides of your breath. You know, just like the tides of the ocean go in and out. It's the normal volume of what you breathe at rest, not when you're trying to do anything extra or anything less, just the normal volume, the tidal volume. And then the next volume we're going to talk about is this big peak. So on this graph, when you see something go up, you are going to be breathing in. We call that inspiration, right? You're taking air in. Because what a spirometry graph does is measure the volume of air that's going in and the volume of air that's going out. So down here, these numbers are actually going to be represented by like negative volumes. That's just how the spirometer would read the graph. But we exhale air, and in a sense, that is like negative volume in our lungs because we're pushing it out, right? So just keep that in mind when we're looking at the graph. Okay, so back to this peak. So the tidal volume here, we talked about when it goes up, that's breathing in, and when you go down, that's breathing out, but that range in between is a normal breath. If you went and sucked in all the air that you could suck in, we would call that your IRV, which is your inspiratory reserve volume. Kind of makes sense. If inspiration is when this graph goes up, the very highest peak is the most amount of air, the biggest amount of air that you could breathe in at any given time. So if you had to guess what this range is, it's the amount of air that you can absolutely breathe out. And we call that the expiratory reserve volume, because guess what? It is what you can expire. It's the total reserve volume that you have that you can push out at any given time. And I know that these don't exactly line up. In reality, with a spirometry graph, you're going to be estimating these lines anyway. But for the sake of the diagram, let's just keep going. Okay, so there is a certain measurement that we like to talk about in terms of spirometry. There are lots of different ones that are actually helpful, because it would kind of suck if every single time we wanted to look at each individual portion of this graph. So for example, this, sideways line, sorry. This big peak right here from the top of the IRV through the tidal volume down to the ERV, the component of all of those is what we call the vital capacity, which is VC. And what the vital capacity actually is like the functional volume that you have at any given time. It's what you normally breathe plus what you can breathe all the way in and all the way out. So if we were going to write that as a formula, the vital capacity is equal to the tidal volume, this region, right? Plus the inspiratory reserve, which is this region, kind of. Like I said, my doodles aren't completely correct. Plus the expiratory reserve, which is this region. So all of those together make up the vital capacity. Okay, so now one thing that you might not think about when you're first looking at this graph is that we don't want every bit of air going out of the lungs, right? You've heard of lungs deflating before for whatever reason. Maybe they've been, punctured or whatever. The lungs should always have a certain amount of air in them left over so that they don't collapse. We call that the residual volume, the RV. Residual meaning what's left over in the lungs, right? Okay, so then the last measurement that I wanted to talk about was this thing called the total lung capacity. You can kind of guess what that's going to be. Total lung capacity, TLC. That is when we take the vital capacity here plus the residual volume to see what the total capacity of the lungs is when we're talking about the functional part of the volume of the lungs, but also the part that's left over. So if we had the total volume that can go in and out of the lungs, that's total lung capacity, which is nice because it could show us a more generalized function of the lung versus like specifically looking at what's going wrong. So if we were to write total lung capacity as a formula, it would be the vital capacity, VC, plus the residual volume. And just by nature, the residual volume is known to be about 1.5 liters. That's kind of like a constant. Okay, so one final thing that I wanted to talk about was this thing called the minute volume. It totally makes sense to me, but it's always, worth going over. So each time you breathe, we have the tidal volume, right? The TV, it's this region up here. And let's say, for example, that your tidal volume was measured at 0.5 liters. That's like an estimate for what's quote unquote normal. I want to know how much air is going in and out of the lungs over the course of a minute. So if I wanted to do that, all I would have to do was take the tidal volume and multiply it by the breaths per minute, which is pretty easy to calculate. You can just measure that on your own. So let's say I counted and I got 16 breaths per minute, not beats per minute like you would normally see. So in that case, I would just take 16 times 0.5, which is pretty easy. It's 8 liters. So the minute volume for that person would be 8 liters. So it's just the tidal volume times breaths per minute. That's a problem that you will have to see or that you will do in the future. So just wanted to walk you through that. But this is the sample spirometry graph. Hope it was helpful.